Good afternoon, everyone. Welcome back. Okay, good afternoon, Anagha. Yes, Kinjal, Shabri. Okay, good afternoon, Anjali. Very good afternoon to all of you. Avni, yes, Avni. Okay. So last time we have been talking about probability distributions, right? Remember? And then in that we are also talking about like we talked about which are the ones for discrete variables and which is the one for continuous. So for discrete we are studying two of the probability distributions. The first one is the binomial and the second one is the Poisson. And for the continuous, we're going to study the normal. Okay. And that also we would go further to talk about the standard normal variant. Okay. And yeah, last time we also took the example of orders in a coffee shop, and then we were able to find, like, understand basically what you can find using the binomials, what you can find using the Poisson, and what you can find using the third one, that is the normal variant. Okay. Okay. Good afternoon, Sakshi, Nancy, Renuka, Anuj, Sejal, Priyanka, Hitesh. A very good afternoon to all of you. Okay. Now let's go ahead. So I think I'll quickly, we already discussed this. Okay. So we are talking about theoretical distributions, and then we talked about that while frequency distribution is giving us the data points, the probability distribution is giving whether or not the data points will occur. Okay. Just a little bit. Okay. Then we talked about the importance also. It is used for short-term projections. Then we talked about the application of binomials. So where the trials are independent. Okay, and so first important thing for binomial is that the trials are independent. Then they have only two outcomes, success or failure. Okay. And so you will use it for tossing experiments, sampling, and genetic experiments, and so on. Okay. And binomial is coming from the Bernoulli trials which are independent, identically distributed, and the outcomes are 0 and 1. Then we talked about the features of binomial, where we talked about success and failure. Then we talked that trials are independent. Then if we represent success with P, then failure is represented by Q, which is equal nothing but 1 minus P, or more importantly, P plus Q is equal to 1. Once you know that, that is more than enough. Okay. Then the number of trials is a finite positive integer. Okay, just mark this because this is one of the theory questions, like number of trials is a finite positive integer. Then we talked about the formula. Fx is given by Ncx p raised to x q raised to n minus x. Okay. And what are the values that x can take? 0, 1, 2, 3, up to what? Up to n. This is also very important because in the theory question, they may put it to infinity, then that will not be a binomial. And it is equal to 0 otherwise. Means what? If I have 1.2, 1.3, we will not be using this. X should take only the discrete values. Then what is important is that if I add all this f0, f1, f2 up to fn, it should give me equal to 1. So summation fx, which is what? Addition of f0, f1 plus f2 plus so on plus fn. This should be adding up to 1. Then we have binomial distribution is known as biparametric. Why biparametric? Because the parameters that describe a binomial distribution are two. Okay, which are those? N and P. And mean is given by N into P. Okay. And then we talked about mode being unimodal or bimodal. And then we talked about variance to be equal to NPQ. Okay. And this if non-integer and if it is an integer. Okay. Then we talked about when there are two independent probability distributions, binomial, which are binomial in nature, and we want to add them, what will happen? Okay. Then we found the solution also. Okay. The important thing that you have to remember is the method used usually applied for fitting a binomial distribution is the method of moments. Okay. Simple questions that you just need to understand, nothing to mug up. Okay, now we begin with the binomial Poisson distribution. Okay. Good afternoon, Renuka, Anuj, Sakshi, Sejal, Priyanka, Hitesh, Hina Kumari, Heni Kumari, then Nishi, Sunil, Anurag. Yes, Nishi. Okay, Anuj, NNP. Yes. Okay, mode also. Very good, Anuj. Yes, Nishi, you can just put in whatever doubt you have in the chat box. Okay. And also remember that you will not be asked to actually fit in a binomial distribution because those questions are long ones. Okay. So that is more for your understanding how you, how if in case it is required, because we would like, institute would like the book to be as wholesome about the particular topic as possible. Okay, but we have to also consider the passing the exam point of view. This is an excellent book for understanding, and also we have to see that whether or not such a question can come for my MCQ. Okay, now Poisson. It is a theoretical discrete probability distribution. The theoretical discrete probability distribution. TDPD. Okay. Okay, there is a chart type called as SPDP. Those of you who have eaten would know that. So this is similar to that. This is TDPD. Okay. So what TDPD means? Theoretical distribution, theoretical discrete, and then probability distribution. Okay. So in case like, you must have the small uh, acronyms or small words, those are the trigger words. Okay, TDPD means because in the question they may ask you whether Poisson is a continuous or discrete, and in the heat of the exam and all those things you may get confused. So for that I must tell you that you use those small things. Okay. Now, what does Poisson say? Let us think of a random experiment under the following condition. So what we do is we take a small interval t and t plus dt. Okay, we've done this plus dt in integration differentiation. So we take a very small interval of time t and t plus dt. Now finding the probability of success, that is probability of success is equal to kt, where k is a constant. Okay, then the probability having more than one success in this time interval is very low. So what they say is in this only one, that is kt, you can have. Okay, the probability of having success in this time interval is independent of t as well as earlier successes. What does this mean is that it is not dependent on whether the earlier one was what. Whether it was a success or a failure will not have any impact on the present trial. Okay, so see, what again the same thing. What we have to do is we have to understand that the Poisson in this case model is e raised to minus kt raised to not r, kt raised to x upon x factorial. Okay. Now, very importantly, x can take the value 0, 1, 2 up to infinity. Okay. Just this is what you are so very happy about it that you've done this some correctly, and then just because you did not pay attention to the small details. So, okay. So, in this case, now what we do is we are putting kt as m, and then we get fx to be equal to e raised to minus m raised to x upon x factorial. What is m? M is the mean of the probability distribution. Okay. So we are going to play around with this formula. Now, there are certain, again, I'm emphasizing on which of the theory parts is important from the point of view of the exam also and understanding also. Prachi, hi. Mahi, good afternoon. Okay. Okay. Now, since e raised to m is equal to e raised to minus m, you can write it as 1 upon e raised to m. You remember a raised to indices, a raised to minus m can be written as 1 upon a raised to m. Whatever may be the value of m, m is always greater than 0. Okay. It follows that fx is greater than or equal to 0 for every x. Okay. So, my probability is greater than or equal to 0 in this case. Okay. Poisson distribution is known as uniparametric. Uniparametric. Means what? It is defined by only one parameter. What is that one parameter? It is m. Okay. So the mean of the Poisson distribution is given by m, that is mu is equal to m. So this is mean. And variance is what? Variance is also m. Okay. Variance is also m. So the mean and variance for a Poisson are equal, which is equal to m. Now for mode, what happens? Mode, it can be again unimodal or bimodal. Okay, same thing, what we did last time. The largest integer contained in m if m is a non-integer, and m and m minus 1 if m is an integer. Okay. So same thing. I will see m. If it is an integer, what will the parameter be? m minus 1. If it is not integer, just take the largest integer or the integer part of this number. Okay. Cool. Then we know about Poisson's approximation to binomial. So if n number of trials of a binomial, so we take the binomial. We know it is defined by 2, n and p. What happens? N is tending to infinity, means n is becoming large. And what is p? P is tending to 0. Oh, sorry, not infinity, 0. Okay. But n into p must be finite. Okay. Okay. So you will have n which is very large, which is nearing infinity, and p going down very small. I mean, the probability is decreasing, like very less. But the multiplication of them must give you a finite answer. In that case, what will happen? We can, the binomial can approximate to Poisson, and where m will be equal to n into p. The parameter that defines a Poisson will be m, and which can be defined by n into p. Okay. So I just repeat, e raised to minus m is equal to 1 upon e raised to m. Fx is greater than or equal to 0. Addition of frequency of the probability must be equal to 1. Poisson is a uniparametric distribution where the mean is equal to variance is equal to m. Okay. There can be again two modes. If it is an integer, then there will be two modes. integer, then you can have a mode at m and m minus 1. If it is not an integer, if m is not an integer, then you will take only the integer part, largest integer part of that number, and that will be your mode. Okay. And then we talked about approximation. N should be tending to infinity and p should be tending to 0, but n into p must be finite, and so you get binomial then approximated by a Poisson. Then again, like if we had two binomials, if you had two binomial distributions, you could add them. Similarly for Poisson also you could add them. So you can have p of m1 plus m2. This is uniparametric. So addition of two Poisson distribution is not a big problem. Prachi, good afternoon. Uni means one. Yes. Anuj. Yes. Okay. Now, where do I apply the Poisson? Like in binomial, we said it was applicable to wherever there is a success or failure, kind of like tossing of a coin, genetic engineering. So there you find the application. What about Poisson? So in Poisson, what happens is that your n is large, your p is comparatively small. So when are the conditions where your n is large and p are small? For example, finding the printing mistakes in a book. Okay. So the number of pages will be large, and the uh, expectancy or the probability of having a misprint is small. So P is small, N is large, but N into P is finite. So I have a Poisson equation. So total number of events is pretty large. Okay, so now about for a second example is there is the traffic on a road. The traffic is large, but the number of accidents is small. So in that case, you will use the Poisson. So distribution of numbers in the printing mistakes, road accidents, radioactive elements per minute in a fusion, and demands per minute after for health center, etc. Okay, so what will happen here is that you should always read the examples given in the book, in the study material. Why? Because they may take an example from there and put it in as a question. So you've already read those examples. ये तो मुझे आता है करके छोड़ देते हैं ना हम, तो वैसा नहीं होना चाहिए. ओके, हमें ये देखना चाहिए कि इसमें हम जितने एग्जाम्पल्स बुक में दिए हैं वो हम पढ़े, वो समझे कि वो है, और प्रिंटिंग मिस्टेक की जो प्रोबेबिलिटी वो कम होती है, इसीलिए वो पॉइजन में बैठता है, और वो डिस्क्रीट है. वरना वो कंटिन्यूस में भी जा सकता था, लेकिन डिस्क्रीट है ना, नंबर ऑफ मिस्टेक्स जो है पेज पे आप वो देख सकते हैं, काउंट कर सकते हैं, तो इसलिए उसको हम पॉइजन में लेते हैं. So anytime, why we must understand this is not necessarily they will give the same example, but once I have applied my mind, applied my logic to understanding which of the three distributions is applicable, what happens is that can be done easily. Yes, Anuj, exactly. Now, for example, let us see the question. Which one is not a condition of Poisson? Okay, so always remember negative questions, you have to be careful. Which one is not a condition of Poisson? The probability of having a success in a small time interval is constant. Do we have constant? No. Okay. So which is not a condition. Okay. So this word not is very important. The probability of having success more than one in a small time interval is in a small time interval is very small. Yes, this is right. This is the condition 2 that we had put here. Where is this condition 3 conditions? Okay, this is my C1, this is my C2, and this is my C3. C1 says the probability of finding success is in a very small time interval is kt, where t is a constant. The probability of having more than one success in a time interval is very low, c2, and the probability of having success in this time interval is independent. Okay, so let us see the question. So the probability of having success more than one in the same time interval is very low. So this is my C2. The probability of having success in a small time interval is independent of time, independent. So this is C3, right? The probability of having success in a small interval t and d plus t plus dt is kt for a positive constant. Yes, this is C1. So C1, C2, C3, all three conditions are met. The probability of having success in a small time interval is constant. We know which is not true. Okay, so A will be the correct answer. Anushka, clear? Yes, very good. Option A. Excellent, Anushka. Next one. Which one is a uniparametric distribution? Binomial, we have two. Normal also, we have two. Binomial, which are the two? N and P. Binomial, you will have mean and variance. Okay. Hypergeometric it is again a discrete distribution and which is out of syllabus. Okay, so naturally they won't expect you from this. So what happens is 1 2 3. Now I will see binomial, I know has two parameters n and p. Normal, even though you don't know just now, but it has two parameters again. So uniparametric is the Poisson. Okay. Now for a Poisson distribution, I have to find out. Let's switch on the calculator now. Okay. Now for a Poisson distribution, mean and standard deviations are equal. Mean and variance are equal. Standard deviation and variance are equal. Both A and B. Okay. Now, again, what happens is this can be a little tricky because we know that variance and mean is equal. But in a hurry, we may even talk about standard deviation. But for a Poisson, mean is equal to variance. D is both A and B. That is not possible. Either mean can be equal to standard variance, standard deviation, or mean can be equal to variance. Okay, not both. Standard deviation and variance are equal. Standard deviation variance are they equal? We know standard deviation is what? Under root of sigma square. Okay. This will hold only true for standard deviation equal to 1, right? Only then will these two be equal. But other than that, so this is not possible. This is not correct. This is the correct answer. So B is the correct answer. Yes, option B. Anushka is on a roll. Yes. Anuj, yes. Correct. Anuj, Kritika is correct. Yes, very good. Then Poisson distribution may be unimodal or bimodal, multimodal or A and B. Okay, so this is like we did for binomial also. D is the correct answer. Yes, because it is unimodal sometimes, it is bimodal sometimes. Okay, it's not multimodal. It's not more than two. Okay, I mean it is not only multimodal. It can be unimodal or bimodal. Okay. So Poisson distribution is always symmetric, always positively skewed, always negatively skewed, symmetric only when m is equal to 2. It is always positively skewed. Okay. So we will see that, how it happens. Okay. So once we see, I'm just telling you the theoretical answers. Okay. Next question. आज मेरे गले में थोड़ी खराश है, तो just bear with me. I just need to drink water. A binomial distribution with parameters n and p can be approximated by a Poisson distribution with parameters m is equal to np. Is okay. Again, these are the questions I've selected very carefully so that you understand the words that are very, very important in theory MCQs. Okay. N tends to infinity, correct? Yes or no? Yes. P tending to 0, correct? Yes. N tending to infinity and P tending to 0, correct? Yes. हम तुरंत इसको आंसर को yes करने को जाते हैं, लेकिन डी ऑप्शन आप पढ़िए. N tends to infinity, P tends to 0, so that NP remains finite. This is the correct answer. Okay, this is the correct answer. So, even though C is correct, but it is incomplete. What is complete is D. D is giving you the correct answer. For Poisson fitting to a observed frequency distribution, we equate the Poisson parameter to the mean of the frequency distribution. We equate the Poisson parameter to the median of the distribution, or we equate the Poisson parameter to the mode of the distribution. So, we equate the Poisson parameter to the mean. Okay. So, A is the correct answer. Again. Number of misprints per page of a thick book. So, number of pages will be large. Number of mistakes will be small. So, where does this happen? This happens in the Poisson distribution. Okay. Okay, let us do some sums. So if the standard deviation of a Poisson variate x is 2, what is P 1.5 less than x less than 2.9? Okay, just let me get my calculator on. Yes. Now, what is the formula? Formula says fx is equal to e raised to minus m raised to x upon x factorial. Okay. And x can take the values 0, 1, 2 up to n. Okay, 0 and 2, etc. Now what happens is, if the standard deviation of Poisson variate is 2, okay, so what do I have? M is given to me as 2. No, not M, sir. Standard deviation. Okay. Standard deviation is given to be 2. And variance is what? Variance is standard deviation square. And what is it? 2 square, which is equal to 4. For Poisson distribution, we have mean to be equal to variance, which is equal to 4. Okay. So now I have to see. Now I have to see the interval 1.5 less than x less than 2.9. Which is the integer in this? Integer lying between. Okay. So this is my number line. This is my 0. This is my 1. This is my 2. And this is my 3. Okay. Now where will my 1.5 lie? 1.5 will lie somewhere here. Where will my 2.9 lie? It will lie somewhere here. So which is the integer between this range? Which is the integer between this range? Only 2. So what do I have to find? I have to find only f of 2. Okay. Now f of 2 will be equal to e raised to m is what? M is 4. E raised to minus 4. 4 raised to 2 upon 2 factorial. Okay. So my x is nothing but 2. Now e raised to minus 4 is already given to me. This is equal to 0.01831. This 4 square is 16 and 2 factorial is 2. Can you calculate and tell me the value? What values will I get? Excellent. Anushka, Priyanka, Nancy, Anuj, Mahi, Kinjal. Yep. Yes. Any Kumari. Excellent. Excellent. Yes. Nishi, standard deviation per Poisson. Standard deviation is variance square root. Standard deviation is equal to variance square root. Okay. So this is equal to square root of sigma square. Okay. Which is equal to square root of n. Yes. Anybody with the answer? Option. 1.146. साक्षी ये 0.18 यहाँ दिया हुआ है ना 0.018 आपको दे रखा होगा या आपको फिर वो टेबल्स दे दिए होंगे वहां पे हो जाएगा यूजुअली दे देते हैं ठीक है ये एक्सपेक्टेड नहीं है टू वैसे आप कर सकते हो अगर आपको फिर भी नहीं पता है तो मैं बता देती हूँ ई की वैल्यू क्या होती है यहाँ दिखा देती हूँ ओके जिनको नहीं मालूम वो समझ ले ई होता है 2.72 ये मैंने सिंप्लीफाई किया है तो हमारे पास क्या है ई रेस टू माइनस 4 यानी 1 अपॉन ई रेस टू 4 विच इज इक्वल टू 1 अपॉन 2.72 रेस टू 4 करना होगा तो इसको पहले हम 4 रेस टू 4 कर लें कितना होगा 2.72 into 2.72 into 2.72 into 2.72 ये आता है 54.74 1 डिवाइडेड बाय 54.74 आता है तो 1/54.74 उसको अगर हम डिवाइड करेंगे तो इसको आता है 0.018 ठीक है हाँ अनुज सो फास्ट यू आर सो गुड रियली कृतिका 0.146 हाँ 0.14 आपका सब लोग का सही आया है वेरी गुड वेरी नाइस ओके यस अभी देखते हैं नेक्स्ट सम इज दिस वन if the mean of a Poisson variable x is 1, what is P of x takes the value at least 1? Okay, now this is very interesting because this is using all the concepts that we used in permutation combination. Then you must have used it again in the probability. See, when we are saying takes the value at least 1, okay, so this is my number line. दिस इज माई 0 1 2 3 और इस तरह ये लाइन आगे जा रही है एटलीस्ट 1 माने क्या होता है मीन्स ऑल थिंग्स फ्रॉम हियर ओके ऑल थिंग्स फ्रॉम हियर इधर से नीचे जाएंगे तो क्या हो जाएगा लेस देन 1 हो जाएगा इधर के ऊपर जाएंगे तो क्या हो जाएगा मोर देन 1 हो जाएगा ओके तो हमें क्या चाहिए हमें ये चाहिए तो ये हम कितना कैलकुलेट करेंगे ये तो अनएंडिंग है ना आई कैन गो ऑन एंड ऑन सो व्हाट डू आई डू एंड आई नो दैट प्रोबेबिलिटी इज 1 total probability has to be 1 in either any distribution you use so what I'm going to do is I'm going to find 1 minus p x less than 1 okay I'm going to find p x less than 1 एटलीस्ट 1 है ना इसलिए हमने ये लेस देन है वरना अगर मोर देन 1 होता तो लेस देन और इक्वल टू साइन होता है ये भी समझ लीजिए कि कब हमें इक्वल टू यूज करना है कब नहीं यूज करना है व्हाट माय एक्स इज एक्स टेक्स द वैल्यू एटलीस्ट 1 okay x takes the value at least 1 means what it is meaning that it is going to take at least 1 so my what am I going to subtract ये at least 1 है मतलब यहां से उनको लेना है so what I'm going to do is up to 1. Okay, so from here to here, this is my total probability. This is my total probability. Out of that, I remove this portion. If I remove this portion is what is the answer I need. Okay, so what I'm going to do is then my probability of x greater than or equal to 1 is equal to probability 1 minus p x of 1 x less than uh, x less than 1 now what is the integer which is less than 1 what is the integer which is less than 1 only 0 right so because I know that x cannot be negative okay so this is equal to 1 minus p of 0 okay this is equal to 1 minus p of 0 now what is my m if the mean of the Poisson is 1, so m is given to me as 1, x is how much? 0. So what is my P0 equal to be? 1 is equal to e raised to minus 1, 1 raised to 0 upon 0 factorial. Okay. Again, one very important. This is the first important thing. Second important thing is 0 factorial is always equal to 1. Now, therefore, it means e raised to minus 1 is 0.3676 is equal to 0.3676. 1 raised to 0, always remember a raised to 0 is always equal to 1. So, this is into 1. 0 factorial is also 1. So, answer is 0.3676. ये लेकिन हमें P0 मिला है अभी फाइनल आंसर नहीं आया है ओके सो व्हाट विल बी माय फाइनल आंसर final answer p of x greater than or equal to 1 is equal to 1 minus p of 0 which is equal to 1 minus 0.3676. Now what is 1 minus 0.3676 is 0.6324. So यहाँ पे ऑप्शन में क्या है 0.632. So 10C will be the answer. Okay. Yes, Nancy, very good. Anil 0.9 is for what? Kritika, correct. अनुष्का, यस, वो पहले वाला आंसर में आपको अप्रोक्सीमेट करना है. हेनी कुमारी, यस, सी इज करेक्ट. Anuj is correct. Kritika is correct. Nancy is correct. Now let us go to the next sum. So you've understood? Okay. Just write it over here. Important thing for distribution is sometimes it happens that you know everything, but just because the sum comes together, the concept individually but you have to apply them together. Okay. So what is that? The total probability is always equal to 1. Okay. So that is why I couldn't do that. That P of x greater than or equal to 1 is equal to 1 minus P of x less than y. Okay. This is possible because of this. Second thing is that I must know that 0 factorial is 1. Third thing, I must know that a raised to 0 is always 1, because this is what we are applying over here. So the concept that we learn in mathematics first and second chapter, those are also applicable over here. Is that correct? Yes, very good. Now this is again a very interesting sum. Now I have coefficient of variation. Remember, you studied that? Coefficient of variation is given by sigma upon standard deviation upon mean into 100. Okay. This is one very important concept. Second important concept that we are going to use is for Poisson distribution, x bar is equal to sigma square. Okay. Why? Because mean is equal to variance. Okay. So very unique concept we are going to apply over here. Okay. What is the probability that x would assume only non-zero values? Okay. Non-zero values means what? P x is greater than 0. Okay. P x is greater than 0. Now, third concept that I'm going to use is total probability is equal to always equal to 1. So non-zero p x greater than 0 means it is equal to 1 minus p x less than or equal to 0. P x less than or equal to 0. Now what is the integer? What is the value that x can take, integer value x can take, which is less than 0, which is 0 or less than 0. So only 0, because less than 0 it becomes negative. I know x cannot be negative. Okay. So it is 1 minus p of 0. So I have put in what is all important for me. Now let us dive into the sum. So first important thing I'm using is coefficient of variation is equal to sigma upon x bar into 100. Second important thing I'm going to use is the total probability is always equal to 1. Third thing I'm going to use is x cannot be negative, and so x less than 0, less than or equal to 0 means x can take the value only x is equal to 0. Fourth thing that I'm going to use is that for a Poisson distribution, x bar is equal to variance. That is, mean is equal to variance. So x bar is equal to sigma square. Okay. Now, using this in the coefficient of variation formulas. Okay. So C of V is sigma into upon x bar into 100. Okay. Now for sigma, what can I write? For x bar, let me put it that way easier. Sigma upon sigma square, ये कहाँ से आया? यहाँ से आया. Into 100. इसकी वैल्यू कितनी है? 50. So 50 is equal to 1 upon sigma is 100 upon sigma. So what is the value of sigma? Sigma is 100 upon 50, which is equal to 2, right? Which is equal to 2. Now, what will be the mean? Mean will be equal to sigma square, which is equal to 4. 2 square is 4. Now, what will be my formula? I, I need p x greater than 0 is equal to 1 minus p of 0, which is equal to, let me find p of 0. P of 0 is a raised to, what is m? That is e raised to minus m, m raised to x upon x factorial. This formula I am going to use. So, e raised to minus 4, 4 raised to 0, 4 raised to 0 upon 0 factorial. Okay. So, how much will this be? E raised to minus 4. E raised to minus 4 is given to me as 0.018315 into 4 raised to 0. I know is 1 because I'm again using fourth concept. A raised to 0 is equal to 1. And 0 factorial is also equal to 1 upon 1. So answer is what? 0.18. So what am I getting? This is equal to 0.018. Our final answer is what? P of x greater than 0 is equal to 1 minus P of 0, which is equal to 1 minus 0.018, which is equal to how much? 0.982. Okay, can you appreciate that this is the correct answer? They have purposefully put 0.018 as the first choice because what happens? I find P0, I get this answer. अरे आंसर आ गया, लेकिन नहीं, हमें 1 माइनस भी करना है. ठीक है, तो आपको इसलिए उसको ध्यान से करना पड़ेगा. Okay, any other questions? SD upon mean. Yes, Anuj, correct. Priyanka, correct. Anushka, yes, very nice, Anushka. Anush, Kritika, correct. That's okay. Yes, Anushka, that's what I was trying to tell. That एक बार आंसर आ जाता है, हम इतनी खुशी खुशी हो जाती है कि 1 मिनट के से कम में हमने आंसर कर लिया. नहीं वो नहीं, वो तो ठीक है. 1 minus P of 0, yes, correct. Nancy, correct. Henny Kumari, correct. Okay, yeah. Let us go to the next sum. Many times you have this question. If 1.5% of an item produced by a manufacturing unit are known to be defective, what is the probability that a sample of 200 items will contain no defective item? Okay. Now, when I read such a question, how do I know whether to use binomial or whether to use Poisson? Obviously it is a number of defective items, so normal distribution आएगा नहीं, क्योंकि normal तो होता है continuous के लिए, height है, weight है, उन सब चीजों के लिए. यहाँ तो हम गिन सकते हैं ना कितने items defective है. So अब मेरे को उसमें से ये देखना है, हमें उसमें से ये देखना है कि binomial या Poisson. बाइनोमियल क्या बोलता है कि सक्सेस या फेलियर. ओके, यहाँ पे क्या हो रहा है, हमें ये पूछना है व्हाट इज द प्रोबेबिलिटी दैट अ सैंपल ऑफ 200 आइटम्स वुड कंटेन नो डिफेक्टिव. ओके, सो आई एम टॉकिंग अबाउट अ सैंपल. So what is happening? N is how much? N is 200, which is large. And P is 1.5%. Percent here means this is 1.5 upon 100, which is equal to 0.015, which is very small. And so I would use the Poisson. Okay. Now for a large n and small p, use m is equal to n into p. मतलब दिखने में जो लगता है कि दो पैरामीटर्स है, n भी है p भी है, but because n is very large, p is very small, and n into p is finite. Let me check that. N into p, how much is it? 200 into 0.015. 15 twos are 30, 30, and then two zeros. So 1, 2, 3, 1, 2, 3. So this is 3, which is finite. Okay. So वो भी हमने करके देख लिया कि वो यहाँ similar. Okay. So I now know that instead of binomial, I'm going to use Poisson. Okay. Now, once I've done that, I have to find what is the value of m. What is the mean? What is the defect? So this is 200 is my n, into p is what? 0.015, which, and this is giving me 200 into 0.0153. What is this? This is mean. M is equal to NP, and we are going to do this. Now, what I know, then what is the probability that there will be no defect? So X is 0. So X is 0 for no defect. This is equal to e raised to m is minus 3, m is 3 raised to 0, and 0 factorial. So this is e raised to minus 3, 3 raised to 0 is 1, 0 factorial is also equal to 1. And e raised to minus 3 is equal to 0.049. Okay. And which will be the answer? A will be the correct answer. MS3, Anushka, very nice. Nancy is correct. For a Poisson variate, x, p, x is equal to 1, p, x is equal to 2, what is the mean of x? Okay, so they have given us p, x is equal to 1 is equal to p, x is equal to 2. Okay. They want us to find m. And they've already given it's a Poisson. Okay. So they want us to find m. So what we know is p of x is equal to e raised to minus m, m raised to x upon x factorial. That I know. So p of 0 is equal to e raised to minus m, I don't know, m raised to 0 upon 0 factorial. What am I going to use? A raised to 0 is 1, and 0 factorial is also equal to 1. So this becomes e raised to minus m. So my LHS is this much. Let me see about the RHS. RHS is P of 2 is equal to e raised to minus m, m raised to 2 upon 2 factorial. So this is equal to e raised to minus m, m square upon 2, because 2 factorial I know is always also equal to 2. Now I need to equate them. P of 0 is equal to P of 1. Oh dear. 0 कहाँ से आ गया? I have to find P of 1. LHS is okay, my bad. X is 1. Okay, X is 1. So P of 1 is e raised to minus m, m raised to 1 upon 1 factorial. So this is e raised to minus m into m. So I am going to use P of P of 1 is equal to P of 2. P of 1 is e raised to minus m into m, and P of 2 is e raised to minus m square upon 2. Okay. अभी e raised to m दोनों साइड्स पे ये कैंसिल होगी. यहाँ m है, यहाँ इक्वल टू के बाद में m स्क्वायर है, तो ये m कैंसिल हो जाएगा. सो देयरफॉर आई हैव 1 is equal to m upon 2 and m is equal to 2. So C will be the correct answer. सेपरेटली शोन इट. अगर मुझे जब स्पीड आ जाती है ना, तो मैं यहाँ डायरेक्टली लिखती हूँ P of 1 is equal to P of 2 e raised to minus m raised to 1 upon 1 factorial is equal to e raised to minus m square upon 2 factorial. ठीक है, ये e raised to m मैं यही कैंसिल कर देती हूँ, ये m raised to 1 और ये कैंसिल कर देती हूँ, तो आता है 1 is equal to m by 2. लेकिन मैंने ये पूरे स्टेप्स आपको इसलिए दिखाए कि कईयों को अगर थोड़ा सा अभी प्रैक्टिस की जरूरत है तो वो ये देख के कर सकेंगे आराम से. ठीक है. हाँ, 13C, Anuj, Nancy, Avni. Yes, very good. Kritika is correct. Anushka is correct. Yes. If 1% of an airline flight suffers a minor equipment failure in an aircraft, what is the probability that there will be exactly two such failures? So P of 2 I need in the next 100 flights. Okay. So my sample space is how much? Sample space is equal to 100 flights. What is my defect rate? 1%. Failure rate, not defect here, failure. So 1% of 100 is equal to 1. Okay, 1% of 100 is equal to 1, which is nothing but m. Which is nothing but m. So I will have f of 2 to be equal to e raised to minus 1 because m is 1, and see m is 1, x is equal to 2. E raised to minus m, 1 raised to 2 upon 2 factorial. E raised to minus 1 is equal to 0.367 into 1 raised to 1 upon 2 factorial I know is 2. So 0.367 divided by 2 is 0.18 kuch to be. So B will be the correct answer. Okay. Yes. So 1 divided by 3.72. It's 1 divided by 3.72. Okay. Yeah. Okay. Next one is for a Poisson variable x, f2 is equal to 3 times f4. What is the variance? Okay. F of 2 is equal to 3 f of 4. f of 2 is equal. Now, can we do it directly? Okay, let me do it directly so that once you know how to do it, we can quickly, like in 2 steps, we can do it. Okay, we know fx is equal to what? E raised to minus m raised to x upon x factorial for a Poisson. Now, f of 2 will be equal to what? If for a, what is the variance? Okay, variance, if I know mean, then I can find variance, but I don't know mean, neither variance. So e raised to minus m, I don't know m raised to, on the left hand side, it is 2 upon 2 factorial, which is equal to 3 into e raised to minus m, as it is m raised to 4, because x is 4 on the right hand side, upon 4 factorial. This e raised to m, this e raised to m gets cancelled. 2 and this cancels, because this is equal to, how much is 4 factorial? 4 factorial is 24. So 2 and 24 will cancel, and I get 12. Then 3 ones are 3 fours are. Okay. So what am I left with is m square is equal to m raised to 4 upon 4. Now this m square, m square, this 2 and this 4, this will cancel to 2. So what do I have? I am left with 1 is equal to m square upon 4. So 4 is equal to m square. So m will be equal to 2. Okay. And mean will be equal to 2. Now what about, what are they asking? Variance. Variance is nothing but equal to mean for Poisson distribution. Okay. So what will the mean be? What is the mean? 2. So what will be the variance be? It will also be 2. Okay. जो भी YouTube पे भी देख रहे हैं, आप समझ जाइए कि आपको पसंद आ रहा है, आपको समझ रहा है, तो आप लाइक बटन भी दबा दीजिए. ओके. इंस्टीट्यूट को बड़ी खुशी होती है, हम जितने ज्यादा लोगों से ज्यादा स्टूडेंट्स तक पहुंच सके, उसमें सबके लिए अच्छा है. इट्स अ विन विन सिचुएशन फॉर ऑल ऑफ अस. ओके. The whole target this time is that all those who are attending these sessions should get the best marks possible. Okay. So, oh, yes, Anuj has said, Poison एकदम clear हो गया है. Enjoying solving questions. Thank you for the interactive classes. Yes, Anushka, thank you so much for being such model students. You know, you are the best. Yes. Okay, I'll just take this one and then we'll go for the break and then we'll go to the normal distribution, I think. Yeah. This is something, this is more for your information. So, in a Poisson variate, the following condition. Okay. तो 9p4 हम क्या करते हैं, x इज इक्वल टू 4 वाला, x इज इक्वल टू 4 है, हम डायरेक्ट p4 लिखते हैं, प्लस 90 p6 इज इक्वल टू p2. ठीक है. अब 9 p4 माने क्या हो गया? e रेस टू माइनस m रेस टू 4 अपॉन 4 फैक्टोरियल प्लस 90 इंटू e रेस टू माइनस m रेस टू 6 अपॉन 6 फैक्टोरियल हो गया इज इक्वल टू p2 e रेस टू माइनस m स्क्वेयर अपॉन 2 फैक्टोरियल. ठीक है. नाउ डिवाइडिंग बोथ साइड्स बाय m स्क्वेयर से निकाल दिया तो क्या हो जाएगा? m स्क्वेयर इंटू ई रेस टू माइनस m. ये अगर आप कर लोगे तो आपको कोई दिक्कत नहीं आएगी. e रेस टू माइनस m स्क्वेयर ऑन बोथ साइड. सो व्हाट विल आई गेट? ये e रेस टू माइनस m निकल गया, यहाँ स्क्वायर हो गया, तो 9 e स्क्वायर अपॉन 4 फैक्टोरियल इज हाउ मच? 24 प्लस 90 e रेस टू m निकल गया, m रेस टू 4 नॉट 6 factorial I know is 720 is equal to e raised to m has gone, m square has gone. So I am left with 1 upon 2. Okay. Now 3 जा 8 जा ये cancel हो जाएगा, 9 8 जा. Okay. So what am I left with is 3m square plus m raised to 4 is equal to 4. Or m raised to 4 minus 3 plus 3m square minus 4 is equal to 0. So what will be the factors? M square minus 1 and m square plus 4, right? 4 plus 4 minus 1 plus 3 is equal to 0. Therefore, m square is equal to 1 or m square is equal to minus 4. Okay. This is not possible. So, answer is m square is equal to 1 and m will be equal to 1. Okay. So, what is the value of p x less than or equal to 1? Oh, I don't have place. This is equal to 1 minus p x equal to 0, right? Only then, because less than or equal to 1. Okay. Sorry, sir. This is already less than. So, this is already less than. So I have p x less than or equal to 1 is p of 0 plus p of 1. Okay. X is less than or equal to 1. So x can take the value 0 and 1. And then I can substitute. So this is what e raised to m is 1, e raised to minus 1, 1 raised to 0 upon 1 factorial plus e raised to minus 1, 1 raised to 1 upon 1. So this is nothing but 2 times e raised to minus 1. What is the value of e raised to minus 1? This. So this is 2 into 0.3678. 3678 into 2. So 3672. So C will be the correct answer. Okay. Has everybody understood this? Yes. Okay. So I think we have done with the Poisson, and after the break, we will be going in for the normal distribution. Okay. Can we take a break, Mohit? Yeah. Welcome back. So we have talked about, the binomial. We have talked about the Poisson, and now we're going to talk about the normal distribution. Okay. Now let us see what the normal distribution is. We have talked that we have the discrete and the continuous. So the two that we have studied till now, binomial as well as Poisson, they are the discrete ones. And now we're going to talk about the continuous one. Okay, so we're going to talk about a continuous random variable. So this is my normal distribution curve. A continuous random variable x is defined to follow normal distribution with parameters mu and sigma square to be denoted by this. If the probability density function of the random variable x is given by this for minus infinity x less than or equal to plus infinity where mu and x are constants. Okay, so this is the formula. But let me first tell you this. Let me try to draw and show you. I mean, this is the very classic one that we always see. I think we've also seen in our school days also. Okay. So you can see these are the tails. Okay. These are known as tails. These tails do not touch the number line. These do not touch the number line. Okay. And this is symmetric. This is symmetric. Okay. If the probability density function of the random variable x is given by. So now let us go to the formula. Now you can see that how is my probability function mu and sigma square. Mu is what? The mean, and sigma square is the variance. Okay. And now what is the formula? Now very carefully. Why I'm taking time to write the formula is because this can be a theory question which you need to be careful about. Like you have to be careful about the plus minus sign. You have to be careful about the range that x can take. Okay. So fx is equal to 1 upon what? 1 upon sigma square root of 2 pi e raised to minus x minus sigma whole square upon 2 sigma x minus mu whole square upon 2 sigma squares. 1 upon sigma square root of under root of 2 pi e raised to minus x minus mu whole square upon 2 sigma square. Now, important thing is minus infinity x is lying between minus infinity to plus infinity. Okay. Can you appreciate this? Also, mu and sigma are constant and sigma is greater than 0. So, you can see how this normal distribution is so different from the binomial and Poisson that we have studied. Yes, Anuj. Normal, continuous, variate. Now, understanding further. Some important points relating is it has its origin some 200 years back as the mathematicians were in search for a normal model, and then we are plotting this, and this is known as what? This is known as the probability probability curve, and it takes this form. This is known as the bell shape. मंदिर में घंटी होती है ना, उस तरह का शेप है, इसलिए उसको बेल शेप बोलते हैं. Now let us go further. So what is this? This is a bell shape. This is a normal curve. How many peaks does it have? It has one peak. So it has one unique mode. Okay. So normal curve is bell shaped. It has one peak and it has one unique mode. The line is drawn through x is equal to mu. Okay. जो लाइन है हमारी, जो लाइन ऑफ सिमेट्री है, वो कहाँ है? मीन पे है. Okay. Such a curve is known as symmetrical curve, and the corresponding distribution is known as a symmetrical distribution. We find that a normal distribution is symmetrical about x is equal to mu. It may be noted that the binomial distribution is also symmetrical, but कब symmetrical होता है? जब मेरी P या Q जो है 0.5 होता है, तो मेरा बाइनोमियल भी सिमेट्रिक होता है. We note that the two tails of the normal curve extend indefinitely on both sides. यहाँ पे जैसे मैंने ड्रॉ किया था वो ज्यादा अच्छा है. ये जो है ना, ये ऐसे दिखाना चाहिए इनको, ताकि हमें पता लगे कि वो लाइन को टच नहीं होने वाला. ठीक है, एकदम पास चला जाएगा लेकिन टच नहीं होगा. बोथ द लेफ्ट एंड द राइट, दोनों जगह पे, लेफ्ट साइड पे भी और राइट साइड पे, दाहिने भी और बाएं भी. ओके. द एरिया अंडर दिस एरिया अंडर द कर्व is equal to 1. So area between minus infinity to mu is the area between mu to sigma, which is equal to 0.5. Okay. तो मतलब क्या है? ये जो पोर्शन है, let me show you. This whole thing is 1. लेकिन if I take only this portion, but take ये वाला हाफ है ना, ये अगर मैं लेती हूँ तो दिस इज इक्वल टू हाउ मच? दिस इज इक्वल टू 0.5. ओके. ऑब्वियसली पूरा जो एरिया अंडर द कर्व है वो 1 है, तो उसको अगर हमने ऐसे, और वो भी सिमेट्रिक कर्व है, उसको हाफ किया तो इट विल बी 0.5. इज दैट क्लियर? यस, 50-50 एग्जैक्टली. अनुज. So now, if we take, now we come to the, this was the general formula that we have. Now we are going to take into consideration what? We are going to take into consideration the standard normal variate. Okay, now see, the area between minus infinity to mu is the area between mu to infinity is 0.5. And area between minus infinity to 0 is 0.5. वही जो अभी हमने बताया. Now let us see if we take mu as 0. Now let us first write down the formula. What is the formula? Says fx. Okay, just a minute. Fx is equal to 1 upon sigma square root of 2 pi e raised to minus x minus mu whole square upon sigma square. Okay, upon 2 sigma square. Okay. Now what happens is, what am I going to do? I'm going to take mean as 0, and I'm going to take mu as 0, and I'm going to take sigma, that is the standard deviation, as equal to 1. Okay. So I'm going to take mu as 0, mean as 0, and standard deviation is equal to 1. So what will I now get? This is known as standard normal variate. Okay. And what will happen? And then I'm going to use, for this I'm going to use the symbol Z. जब मैंने Z यूज किया, इसका मतलब क्या हो जाता है कि इट इज द स्टैंडर्ड नॉर्मल वेरिएट. मीन 0 है, और जो सिग्मा है वो 1 है, और ये कंडीशन सेम है, minus infinity to plus infinity. Okay, the standard normal z, the random variable z is known as the standard normal variate or standard normal deviate. Okay, standard normal variate or deviate. The probability that a standard normal variate would take a value less than or equal to a particular value, तो उसको दिखाते कैसे, हम ऐसे दिखाते हैं, this is phi of x is equal to p, capital S is less than or equal to small x. And this is known as, phi is known as a cumulative distribution function. So when I'm saying that p is x is less than 0, x is less than or equal to 0, it means it is minus infinity to 0.5. Okay? Minus infinity to 0 and the area is 0.5. Okay. Now, obviously, you have two parameters. Which are those? Mean and variance. Okay. So this is, the normal distribution is biparametric and is defined by this. अभी लिखा था ना हमने n of mu and sigma square. आगे पहले लिखा है ना कहीं पे? हाँ. See, this is important. So that is what we are doing. So properties of normal distribution. What, any other questions you have? What is the question? Yes, we are going to study more of the standard normal variate. Yes. Now, let us see the properties. Now, pi is 22 upon 7 and e raised to minus theta is equal to 1 upon e raised to theta is always greater than 0. So, it follows that fx is always greater than or equal to 0. And if I do the integration minus infinity to plus infinity of fx dx, it is going to give me 1. Okay, this is only for theory. We don't have to prove anything. So, you just need to know the properties. Nothing difficult about it. Okay, so don't take any stress over it. We just need to know that if I integrate minus infinity to infinity of the fx, I'm going to get 1. वहां पे जो हमारा डिस्क्रीट वेरिएबल था वहां पे हमने समेशन किया था ना, उसी तरह कंटिन्यूअस के लिए हम इंटीग्रेट करते हैं. ठीक है. The mean of the distribution is given by mu. Further, since the distribution is symmetrical about x is equal to mean, it follows that this is also very important. Okay, mean is equal to median is equal to mode for a normal distribution. Okay, ये सिर्फ इसके लिए, which is equal to mu. ठीक है. Then these are the certain figures that you need to know. Now the standard deviation is given by sigma. मालूम है? Mean deviation of the normal distribution is given by. Okay, so I have mean deviation is given by sigma square root of 2 upon 2 pi. ठीक है. Now 2 pi I know is 2 into 22 upon 7. And if I do this calculation, square root of 2 upon 2 pi, this is going to give me 0.80 sigma. Okay, so mean deviation will be equal to 0.8 sigma. Okay, Again, this is important not only from the point of view of the theory but also from the point of view of the sums. बहुत आराम से वो पूछ रहेंगे मीन डिविएशन बता दीजिए नॉर्मल डिस्ट्रीब्यूशन का, आप क्या लिखना है 0.8 into sigma. Then I need to know, this is the first important one. Second is quartile division. So for that I need to know Q1. Q1 is mu minus 0.675 into sigma. Q3 मतलब third quartile is mu plus 0.675 into sigma. और थर्ड इंपॉर्टेंट है क्वार्टाइल डिविएशन. क्या होता है Q3 माइनस Q1, है ना, हमें मालूम है. तो उतना वो कितना आता है 0.675 सिग्मा. ओके, सो क्वार्टाइल डिविएशन इज हाउ मच 0.675 सिग्मा. ठीक है ना. क्वार्टाइल Q3 माइनस Q1 अपॉन 2 होता है तो इतना आता है. So these are the three important formula. Apart from the general formula that you have, you need to know this. Then the fourth important point is it is symmetrical. Okay. So what is the first point we have done? First thing we have talked about is area under the curve. If I integrate, that is minus infinity to plus infinity, it is going to give me 1. Second is that the mean is equal to median is equal to mode is equal to mu. Third thing is that the mean deviation is 0.8 sigma. The quartile deviation, the Q1 is mu minus 0.675 sigma. Q3 is mu minus 0.67, 0 plus mu plus 0.675 sigma. Then quartile deviation will be equal to 0.675 upon 2. Fourth point we are talking is that the normal curve is symmetric about x is equal to mu. Then fifth point is it has 2 points of inflection. Again, this is important. What are those points of inflection? Mu minus sigma and mu plus sigma. Okay, this is important. And then if n is equal to, x is equal to mu and sigma square, then z. Okay, then z, which is equal to this, x minus mu upon sigma is n of 0, 1 is known as the standardized normal variate of the normal or normal deviate. Variate bolo ya deviate bolo. Okay. So all these 6 points that we have studied are applicable, like you can get questions in your theory. Yes. Now, sometimes there are a lot of questions and sometimes there are no questions. So it becomes really very surprising. I know this topic, normal, is a little bit more, like there are lots of things going on and you have to take one point at a time. But believe me, once you've understood, it is so interesting. Okay. Now, I'm going to explain this, the chart that is there, graph that is there in the book also. Here, see, the starting point is here. X is equal to mu. तो इन्होंने सारे लाइंस एक कलर के किए हैं, तो मैं आपको इधर दिखा दूं. दूसरा कौन सा कलर है, ये वाला ले ले, ग्रीन. ये है ना, ये आपकी लाइन ऑफ सिमेट्री है. दिस इज योर लाइन ऑफ सिमेट्री. ओके. ये जो हाफ है टोटल यहां से यहां तक, ये 0.5 है एरिया अंडर द कर्व. हाँ, और यहां से अनएंडिंग ये 0.5 है. ठीक है. ये भी यहाँ एंड नहीं हो रहा है, कंटिन्यूस जा रहा है, यहाँ पे भी कंटिन्यूस. So that is there. But what will happen when I take z is equal to minus 1, that is mu minus sigma. So how much area will be covered? 34.135. Mu plus sigma 34.135. Okay, तो ये सिमेट्री है, यहाँ पे भी ये इक्वल है, वो तो होना ही है क्योंकि कर्व ही आपका सिमेट्रिक है. तो आप अगर x माइनस सिग्मा और यहाँ म्यू माइनस सिग्मा और यहाँ म्यू प्लस सिग्मा करेंगे तो वो इक्वल आएगा. Then what will happen if from my mean I'm subtracting minus 2 sigma, that is I'm going further, standard deviation I'm going twice. So in that case, how much area will be covered? This much. What will happen if I cover 3 times? So this area will be covered. So this is, so once I try to like put it together, what will happen is this. This is equal to 0.6828. So minus mu minus sigma to mu plus sigma is this much. And ये हम इस म्यू और सिग्मा से बात कर सकते हैं और जेड से स्टैंडर्ड वेरिएट के बारे में -1 to +1 बोलेंगे वैसे. ओके, सो P -1 less than Z less than 1 is equal to 0.6828 area under the curve. Then P of -2 less than Z less than +2, this is equal to 0.9546, and P of -3 less than Z less than +3, this is equal to 0.9973. So मतलब आप देख रहे हैं 9973 मतलब nearly 99, that is 99.73% area is covered. When I go to standard deviation, 3 times my standard deviation, most of the points will be covered by this, okay, by going up to 3 times. So the probability that a value of x, this is also a very important sentence, you know, ये भी theory का बहुत अच्छा सा है. The probability that the value of x lies outside that limit is as low as this much. आप देख रहे हैं 0.0027. ये भी आप ध्यान रखिएगा, वहां पे डेसिमल के बाद कितने जीरोस हैं ऑप्शंस में. दिस इज 0.00. ये कहाँ से आया? दिस इज 1 - 0.9973. ये जो है ना, इसको माइनस किया तो ये आता है आंसर. ठीक है. So now what will happen, like we talked in binomial also, Poisson also, that if I have two binomial, if I want to join them, what will happen? If I have two normal distributions, if I want to join them, what will happen? Now I have Poisson. Now I'm talking about two normal variables. If I have two different distributions of normal distributions, and if I try to join them, so if I have x and y are normal variables with means and standard deviation, पहले वाले का क्या है? μ1 σ1, दूसरे का है μ2 σ2, एंड z जो है वो x प्लस वाई है. उनका अगर हमको एक साथ करना है तो क्या हो जाएगा? देन इट्स स्टैंडर्ड डिविएशन विल बी इक्वल टू स्क्वायर रूट ऑफ σ1 स्क्वायर प्लस σ2 स्क्वायर, एंड व्हाट विल बी द मीन? मीन विल बी μ1 प्लस μ2. ओके, तो जो नया डिस्ट्रीब्यूशन होगा उसका जो पैरामीटर्स है, द पैरामीटर्स ऑफ द न्यू distribution that is formed by joining two existing distributions is given by mu. Mean is equal to μ1 plus μ2, and the standard deviation is square root of σ1 square plus σ2 square. The application for normal distribution is not restricted to statistics. Okay, yes. Now, normal distribution you can use in science also, you can use in management. Why? Because it is considering the continuous variable. So it has a larger um, like playing field. So you, wherever you have like things like profit, you have heights, weights, there you can use the normal distribution. Also, when the number of tries goes on increasing for a binomial, like you have done an experiment and now you want to like translate it to the bigger population, from a sample to the population. If I'm doing that, then my n is increasing very much. So in that case also, I can have binomial tending to the Poisson also, and then I can also have it to the normal distribution. It's how, it's not exactly doing that, but we can translate it to that level. So Poisson distribution for larger values of m approaches the normal distribution. So you can see that binomial distribution goes to the Poisson distribution when n is very large, and Poisson will go to the normal distribution when m is very large. Okay. And this is important that you remember, especially for normal. When you get questions like x is lying between a and b, what does that mean? This is equal to a line, x is line. So this is my number line. Okay. Now this is my a and this is my b. And somewhere here my x is there. So what will happen is x is greater than a but less than b. So you will have b minus mu upon sigma and minus sigma of a minus mu upon sigma. Okay, so this is b minus a. Okay, so this is sigma b minus mu upon sigma minus sigma a minus mu upon sigma. So this is how you have to calculate. Okay, this is the same formula. What we are using here is fx is equal to 1 upon square root of 2 pi e raised to minus z square upon. As usual, I'm trying to take as much as of the theoretical theory questions so that where your understanding improves more. The most important continuous probability distribution is the normal distribution. The probability density function of a normal variate x is given by, see, this is the formula. I've already posted it here. 1 upon sigma square root of 2 pi e raised to minus into bracket x bar minus mu whole square upon 2 sigma square. Now let us see what will happen over here. This matches, and for sigma, for x lying between minus infinity to plus infinity. Okay, so this is correct. Let us see why the others are not there. This formula is correct, but this is wrong. Okay. And over here, what is happening is this sigma is under the square root sign, which is also wrong. Sigma is outside the square root sign. The total area of the normal curve is 1. That we all know. Okay. The normal curve is bell-shaped. The normal curve is positively skewed, negatively skewed, symmetrical. So it is symmetrical. Area of the normal curve lies between minus infinity to mu is 0.1, 0.5. Between mu to infinity is 0.5. So these two are correct. So D is the correct answer. Okay. 32, can anybody answer? 33 rather. Okay, thank you, Sakshi. Sakshi saying your explanation is very easy to understand the concept. Yes, that is what I'm trying. Anushka, thank you so much. Divya, clear. Yes, Anushka, this is the last class for chapter 16. Yes, Anuj, Anushka. Yes. Can anybody tell me the answer to 33? That is what I want. I want you to love the subject. I want you to understand the subject. Yes. And once you do that, passing will not be a problem. Okay, very nice. 33. Anuj is saying A. Let us check. The cumulative distribution function of a random variable x is given by fx p x less than or equal to x, x greater than, less than, and this one. So, what is the correct answer? A is the correct answer. The mean and mode of a normal distribution may be equal, are always equal, may be different. So, they are always equal. There is no mean. Okay. Mean is equal to mode is equal to median. The mean deviation about median of a standard normal variate is. हमने किया था ना वो कितना है 0.8 सिग्मा. ओके हमने किया था उसको मीन डिविएशन कितना था 0.8 सिग्मा. ठीक है. नाउ इम्पोर्टेंट थिंग इज ऑफ अ स्टैंडर्ड नॉर्मल वेरिएट पूछा है. स्टैंडर्ड नॉर्मल वेरिएट में सिग्मा की वैल्यू कितनी होती है 1 बिकॉज वैरिएंस भी 1 है सिग्मा भी 1 है. तो सी और डी में आंसर क्या होगा डी हो गया. ओके so be careful with 35th question. The answer is 0.8. Why? Because we are talking about the standard normal variate. If we had talked only about the normal distribution, answer would have been 0.8 sigma. But because we are talking about the standard normal variate, the value is equal to 1. The value of sigma is equal to 1. And so the answer is equal to 0.8. The quartile deviation of a normal distribution with mean 10 and standard deviation 4 is. Okay. Now quartile deviation formula is what? 0.675 into sigma. Okay. And here see there is no standard normal variate. Okay. So this is talking of the normal variate with mean as 10 and standard deviation as 4. So this is equal to 0.475 into 4. Sorry, 6, not 4. 675 into 4. How much is this? 0.675 into 4. 2.67. Okay. So, C will be the correct answer. 37. For a standard normal distribution, the point of inflections are standard normal. So, what is the points of inflection? Mu minus sigma and mu plus sigma, right? These are the normal points of inflection. But for a standard normal distribution, what will the value be? Mu is equal to how much? 0 and sigma is 1. So, 0 minus 1 and 0 plus 1. So, this is minus 1 and plus 1. So, it will be minus 1 and plus 1. Therefore, C will be the correct answer. The symbol phi of A indicates the area of the standard normal curve between minus infinity to प्लस इन्फिनिटी. ये तो एकदम सीधा सीधा क्वेश्चन है. बस क्योंकि हमारा स्टैंडर्ड नॉर्मल वेरिएट है तो हम उसको एफ एक्स की जगह हम क्या लिखते हैं फाई लिखते हैं फाई ऑफ ए. ओके फाई इंपॉर्टेंट है. आप अंदर सिंबल कोई सा भी यूज कर सकते हैं. ठीक है. Yes, Anuj, Anushka, Kritika, very good. 39th. Okay, now 39th, can anybody tell me? Why I want you to answer here is because the wordings are a little tricky, you know. आपको आता सब है लेकिन वहां पे choice जो है वो which is a better choice rather than which is right or wrong. Okay, so which is going to explain more correctly. So the interval mu minus 3 sigma and mu plus 3 sigma covers what? Yes. Can I get an answer? Anushka is saying A, D. Kritika is saying D. Anybody else? See, they have given the graph also. So if they have given the graph and if I add, what will happen is that it is covering. Yes, C is also correct. A और B नहीं है, ये तो हमें पहले ही मालूम है. C और D में कंफ्यूजन हो जाता है. बट व्हाट इज हैपनिंग हियर इज, इसके लिए हमें ये 2 स्लाइड आगे जाना पड़ेगा, जहाँ पे हमने वो ड्रॉ किया था ना. हाँ. So here what happens is P of -3 to +3 is 0.9973. तो सिर्फ 99% नहीं है. आंसर क्या बोलता है? 99 के ऊपर होना चाहिए. तो यहाँ पे तो आंसर जो सी है, इट इज सेइंग 99% ऑफ द एरिया ऑफ द डिस्ट्रीब्यूशन. सो व्हाट इज हैपनिंग इज दिस इज मोर करेक्ट. Thus, the probability that the value of x lies outside the limit is as low as 0.0027. 0.0027 means what? It is 0.27%, because इसको 100 से मल्टीप्लाई करेंगे तो हमारे पास आंसर परसेंटेज में आएगा. ओके, इसको सिर्फ हमने क्या किया, परसेंटेज में कन्वर्ट किया है. सो दैट इज व्हाई व्हाट इज द आंसर फॉर दिस 39th वन. So this D is the more correct answer. अगर यहाँ पे बहुत कुछ उल्टा सीधा लिखा रहता तो सी मेरा आंसर ठीक रहता, लेकिन दिस इज 99.73, so it is covering an area more than 99%, and D is saying all but 0.27%, so this is a better. तो इसमें वही मैं बोल रही हूँ, आपको लैंग्वेज समझनी है. इसमें ऐसा कुछ नहीं कि आपको नहीं आता, आपको आता है कि म्यू माइनस सिग्मा टू म्यू प्लस सिग्मा कितना एरिया कवर होगा, म्यू -2 सिग्मा टू म्यू +2 सिग्मा कितना कवर होगा, म्यू -3 सिग्मा म्यू +3 सिग्मा कितना एरिया कवर होगा. लेकिन इसमें डी जो है दैट इज अ बेटर आंसर. Ashinka, thank you so much for being here. Till I know it's very difficult to say sit in one place for 2 hours and listening. Yes, Divya, correct. अच्छा दिव्या, अनुष्का चाहती है कि एग्जाम्पल के साथ कि बायनोमियल कब होगा, पोइसन कब होगा. ठीक है, एक 5 मिनट देना अनुष्का, मैं आपको बताती हूँ. ठीक है, एक दो चीजें देख लें. If x and y are two independent normal random variables, then the distribution of x plus y is, hmm? If both are normal random, obviously they are going to be a normal distribution. Okay. So if x and y are independent, this can also be a theory question. Standard deviation is would be square root of sigma 1 square plus sigma 2 square. For a random variable x, the probability density function is given by this. Okay. Identify the distribution and find the mean and variance. Okay. So once this is given, now I have to see whether it is the what is the distribution, which probability distribution, and what I want to find is the mean and the variance. So what I know is what is the original formula for normal. This is equal to 1 upon sigma square root of 2 pi e raised to minus x minus mu whole square upon 2 sigma square. Right? Now here what do I have? So 1 upon square root of pi is equal to 1 upon sigma square root of 2 pi. Right? So what will happen? Squaring both sides. I will have sigma square into 2 pi is equal to pi. ओके, सिग्मा स्क्वायर इंटू 2 पाई, और मैंने वो 1 अपॉन था ना तो उसको फ्लिप कर लिया, स्क्वेयरिंग बोथ साइड्स एंड फ्लिपिंग, मतलब या आपको फ्लिपिंग नहीं समझते तो क्रॉस मल्टीप्लाई. Okay, so what is happening? This is going to get cancelled. So I'm going to have sigma square is equal to 1 upon 2. So what is my variance? So my variance is equal to 1 upon 2. That is what they are asking. Now let us find mean. Now I have e raised to minus x minus 4 whole square is equal to e raised to minus x minus sigma x minus mu whole square upon 2 sigma square. Okay, when bases are same, powers must equate. याद है फर्स्ट चैप्टर में पढ़ा था, एक्सपोनेंशियल्स जहां पे पढ़ा था. So when bases are same, so what I have, minus x minus 4 whole square should be equal to minus x minus mu whole square upon 2 sigma square, right? माइनस माइनस दोनों जगह से निकल जाएंगे. सो आई हैव व्हाट, एंड आई नो द वैल्यू ऑफ सिग्मा स्क्वायर, सो दिस इज x minus 4 whole square is equal to x minus mu whole square. सिग्मा स्क्वायर इज 1 upon 2, सो 2 into 1 upon 2. ये भी कैंसिल हो जाता है, 2 2. तो x minus 4 whole square is equal to x minus mu whole square. Okay, what does this imply? This implies mu is equal to 4. Okay, so you got the answer, right? Okay, thank you, Ashinka. Yes, normal mean is 4, variance is 1. Yes, very nice. 1/2. हाँ अनुज, इसको कंपेयर करके ही करना है, लेकिन मैंने आपको कंसेप्ट बता दिया. आपको वहां पे डायरेक्टली ऑप्शंस में भी जो होगा तो आप देख के तो पता ही सकते हैं ना, वो तो ऑप्शंस वाला सम है ये. लेकिन ये सॉल्व एग्जाम्पल है बुक में, तो इसीलिए मैंने वैसे ही रखा है, वरना आप ऑप्शंस देख के ही समझ जाएंगे, है ना. क्या होगा, जो ऑप्शंस है ना, ये मैं आपको ट्रिक बता देती हूँ. जो ऑप्शंस है वो आप इस फॉर्मूले में डाल ले, ये आपका मेन फॉर्मूला है, उसमें डाल ले जो भी 4 ऑप्शंस होंगे. तो उसमें से एक जो ऑप्शन होगा वो तो आपको ऑब्वियसली ये वाला देगा, 4, 1/2. तो ये वाला ऑप्शन जो है इसमें डालेंगे तो आपका ये आंसर आ जाएगा. ठीक है, लेकिन कभी क्या होता है कि आपको अगर कंसेप्ट अच्छे से मालूम होगा तो आपको इजी जाता है, इसलिए मैंने आपको एक्सप्लेनेशन भी दे दिया. ठीक है, ये हो गया. अच्छा, ओके, ये वाला लास्ट में कर लेते हैं, ये लास्ट हम कर लेते हैं फिर हम लोग रुकते हैं. ठीक है. If the two quartiles of a normal distribution are, so Q1 is 47.30, Q3 is 52.70. What is the mode of the distribution? उन्होंने mode पूछा है. Okay. What do I know? Mean is equal to mode. मीन निकाल लिया तो मोड अपने आप से आ जाएगा. नाउ अभी मुझे मालूम है Q1 कितना होता है. Q1 is equal to mu minus 0.675 sigma. मेरे पास फॉर्मूला है. Q3 is mu minus 0.675 प्लस mu plus 675 sigma. इन दोनों का अगर मैं ऐड करती हूँ, एडिंग, ओके, इफ आई ऐड दीज टू, यहाँ पे अगर मैंने ऐड कर दिया तो क्या हो जाएगा, Q1 प्लस Q3 इज इक्वल टू 2 times म्यू. ये तो कैंसिल हो जाएगा, माइनस और प्लस. Q1 प्लस Q3 कितना है मेरे पास, 47.30 प्लस 52.70 इज इक्वल टू 2 times म्यू. ये तो 0 0 7 2 0 100 हो गया. 100 इज इक्वल टू 2 म्यू, म्यू इज इक्वल टू 50, है ना, 100/250। आगे मीन डिविएशन, इन्होंने क्या पूछा है, मीन डिविएशन अबाउट मीडियन ऑफ दिस डिस्ट्रीब्यूशन, व्हाट इज द मोड, मीन इज इक्वल टू मोड। सो ये तो आ गया। अभी मीन डिस्ट्रीब्यूशन, मीन डिविएशन कितना है, मीन डिविएशन इज इक्वल टू 0.8 टाइम्स सिग्मा। सो आई नीड टू फाइंड सिग्मा। अब मेरे पास एक आ गया तो आराम से दूसरा आ जाए। म्यू आ गया है मेरे पास 50, Q1 इज इक्वल टू म्यू माइनस 0.675 सिग्मा, दिस इज इक्वल टू 47.30, म्यू आ गया 50, 50 माइनस 0.675 सिग्मा। इसको अगर हम सॉल्व करते हैं तो इससे मुझे मिल जाता है, हाउ मच इज दिस, ये इधर लेके आ जाए। सो 0.675 सिग्मा इज इक्वल टू 50 माइनस 47.3, 50 माइनस 47.3 कितना हो गया, 2.7, 2.7 डिवाइडेड बाय 0.675, दिस इज 2.7। So sigma is equal to 2.7 upon 0.675, ये कितना आता है, 4। Okay, so sigma is 4. Now I've got sigma. Now what do I need? I need mean deviation. So mean deviation कितना हो जाएगा, mean deviation about the median is equal to 0.8 times sigma, which is 0.8 into 4, which is equal to 3.2. Is that clear? Yes, very good, very good. Okay, करने के लिए बहुत है, लेकिन अभी टाइम खत्म हो रहा है। सो थैंक यू ऑल फॉर योर पेशेंट हियरिंग, हैव अ ग्रेट डे अहेड एंड आई होप यू हैव अंडरस्टूड the concepts of normal distribution, the distribution for, एक मिनट, अभी किसको चाहिए था ना, दोनों का डिफरेंस, let me just quickly take the common example. Okay, so the example that we took last time, I think Anushka wanted me to repeat it, so just and it's beneficial to all of us. Like consider a coffee shop. The coffee shop receives an average of 20 orders per hour. These orders are independent, and let us assume that the standard deviation is 4. So what does the Poisson give us? It helps us to model the specific number of orders in a given hour. So that if I say I want to find out what is the probability of getting 15 orders, so that I can do using the Poisson. The normal distribution, we'll talk about the range, okay, 15 to 25, because normal is for continuous variable. This is just an example for overall understanding. उसमें से आप अगर पिन पॉइंट करने जाओगे तो बड़ा मुश्किल हो जाएगा। बस हमको ये समझना है, क्योंकि जब क्वेश्चन आता है एग्जाम में तो मुझे ये समझना चाहिए कि हाउ which of the probability distributions I should be able to apply. Then the binomial says that the specific number of an order in a randomly selected time frame, जैसे इस घंटे में, इस आधे घंटे में, इस एक घंटे में इतने ऑर्डर्स, 15 ऑर्डर्स मिल सकते हैं क्या, तो वो हमें मिलता है बायनॉमियल डिस्ट्रीब्यूशन से। बिकॉज आपका वहां पे जो, मतलब जो हर डिस्ट्रीब्यूशन का एक रीच होता है, उसमें यह है कि बायनॉमियल जब इस तरह से बात करता है। ओके, फिर हमने स्क्यूनेस के बारे में बात की थी। I think that's all that is to say. ठीक है, बाकी सब तो हो गया है ना। ये याद रखिएगा, बायनॉमियल इज एन एक्सटेंशन ऑफ द बर्नौली ट्रायल्स। Then we talked about discrete and discrete. Yes. Okay. Thank you all for your patient hearing. Have a great evening ahead, and let us meet then for next time when we meet. Yes. Can we end the session?